All right, so let's take a look at this triple integral here. Um, they're not suggesting a particular coordinate system to use. In other words, rectangular versus spherical versus cylindrical. So we'll just give it a look and see what we think. Okay, first job is always to try and get a picture of the region. So z equals 1 minus y squared. If we want to think about what that looks like, draw an x, y, z axis. And then the 1 minus y squared part, the way I like to think of that is that's just a parabola that's inverted because it's got a minus in front of the y squared term. It's in the zy plane. So that ends up looking like this. It starts off at 1 and then it subtracts. That's pretty bad. Let me fix that. It goes down like that and down like that, and it's intersecting the y-axis in two places. It might be nice to know what that looks, where those two places are. If we're intersecting the y-axis, that would mean z equals 0. And if you do 0 equals 1 minus y squared, then y equals plus or minus 1. So you know that this is 1 and this is negative 1. Now, something you may know from graphing something like this in a 3D world is notice that x is not x has no restrictions here. We don't know how x fits into this relationship. And what that means is you could take this parabola and shift it. So if we want, we can just make a copy of the parabola. Let's see if I can do that. Oh, there we go. There's another one. And I could take this parabola and move it just like that. And what I've done is that's just happening where there's a different x value. Okay, well, we know that one of those x values is x equals 1. So that's over here at x equals 1. We know that this stayed along that line y equals 1. Matter of fact, while we're at it, let's extend x equals 1, make it look like this. So they all meet up at a point here. So there's x equals 1. And then there's another copy of that parabola that we would have. So I'll copy it again. And then I can move it back here because there'll be another one. And that, actually, let's move it over a little bit. Now we can see if I took this line y equals 1, extend it back, and right along here, and then I draw x equals negative 1. Ooh, let's use a different color. Sorry about that. Let's undo that so it doesn't look too sloppy. Here we go. And then I draw a straight line through here. That's x equals negative 1. And now you can kind of see this object. Let's draw the top of the parabolas together. It's sort of like a hill, like the shape of a cake of some kind, a loaf that's curved on top. And what you can tell is, I'll draw in yellow here, you can see that it has this base, which is like a rectangle. So let's go draw that. Let's make a new page here. And so if we're looking down above from this, at this object, from above the XY plane, all we would see is, we would see the lines x equals 1, x equals negative 1, and then I think I drew them in black. Yep, and then I drew the y equals negative 1 and 1 in green. So here's y equals 1, y equals negative 1. And so you'd have this square region, this rectangular region. And that's very easy to describe when in the rectangular coordinate world. So most likely we're going to do something like this. Triple integral, and we'll do something dz, dy, dx. We know that x is varying from negative 1 to 1. Sorry about that. And y is also varying from negative 1 to 1. We're integrating the function x squared e to the y. And they tell us that we're staying between z equals 0 and z equals 1 minus y squared. So I could put that here, 0 and 1 minus y squared. And that's it. So that's the process of setting up the triple integral. It's good to look at the region from above. Actually, it makes it easier. Okay, let's go compute this integral. Let's take a little bit of algebra, but nothing too terrible. So integral negative 1 to 1, negative 1 to 1, 0 to 1 minus y squared, y x squared e to the y. Did I write it that way over there? I did. Good. And we're going to commit to the order dz, dy, dx. Okay, integrating this inside function with respect to z is easy because there's no z's here. So it's just a constant. So your antiderivative is x squared e to the y times z, evaluated from 0 to 1 minus y squared. We plug in y squared, we get x squared e to the y times 1 minus y squared. And when we plug 0 in, because we're going to subtract off what happens when we get 0, you just get 0, so nothing's going to be there. So the next integral we got to do is the integral from -1 to 1 of this thing dy. Okay, so if you don't mind, since we're integrating with respect to y, I'm going to take this x squared and put it outside the integral because it's a constant anyway. So x squared, -1 to 1, e to the y times 1 minus y squared dy. All right, so this problem, this is a nice integration by parts. You can see that you have a function of y times a function of y. If you try use substitution here, you'll be out of luck. So, and also, since 1 minus y squared has finitely many derivatives, sometimes it's nice to try tabular integration by parts. E to the y has infinitely many antiderivatives, so I'll put it over here. The procedure is you take the derivatives on the left, so going down this way, it's d dy's, and this way you do antiderivatives. So let's see, the derivative of 1 minus y squared is -2y, then -2, and then 0. You stop when you get to 0. The antiderivative e to the y is e to the y, e to the y, e to the y. So that was easy. I then connect diagonally and plus, minus, plus. Okay, this is just like a quick version of integration by parts. So if we take the time to write the answer, we end up getting 1. Okay, so we get, oops, my pen back, 1 minus y squared e to the y. And then you have minus here, and then this negative. So it becomes plus 2y e to the y. And then this last term is going to be minus 2 e to the y. And that's your antiderivative. Don't forget this whole thing is getting multiplied by x squared, so we can't forget about that. And this has to be evaluated from -1 to 1, because that's what our limits of integration were right here, -1 and 1. Okay, so just going to plug in -1 and 1 and see what happens. Well, we plug 1 in here, that whole first term goes to 0, so that's gone. If we plug it into the second term, I get 2e to the 1, which is just e. And if I plug it into the last term, I get minus 2e to the 1, which is 2e. Oh, that's surprising. So that just turned out to be 0. I have to do minus whatever happens when I plug in -1. So if I plug in -1 here, it's being squared. 1 minus 1 is 0 again, so that's gone. If I plug it in here, I end up getting -2 e to the -1. And then if I plug it in here, I end up getting just -2 e to the -1. So that looks like we have a -4 e to the -1, but then I'm negating it. So I end up with 4 over e, which is just a number. All right, don't forget about that x squared. There's really an x squared here. All right, so our final integral is the integral from -1 to 1. I'm going to put the 4 over e outside, x squared dx. It would be nice to see problems this easy all the time. Look at this, ready? 1/3 x to the third from -1 to 1. We plug in 1, we get 1/3. Plug in minus, we got -1/3. Then we're getting 2/3 and times 4 over e. So it looks like we're going to get 8 over 3e as our answer. Okay, great. Thanks for watching.